If you like these videos, please check out my full course at www.lsat.totaltestprep.net with tons of clearly explained actual LSAT questions written by someone who's mastered test and helped others master it, and an evaluation period where you only pay if you want to continue.
Okay, so that's that in terms of the basic information. Now, in terms of the logical implications of these statements. So we've got the statements over here on the right. So we're going to, all cats are animals, most cats are animals, some cats are animals. So those are all the same statement, except that they are differentiated by with respect to what syllogistic quantifier they use. So the top one is all, so it's a regular conditional, and then we got most, and then we got some. So as I wrote here, the quantifiers actually logically imply one another in specific ways. And as you see, I've got the arrow going down, so you can actually go from all to most to some. So if you have a statement that says all A are B, that implies that most A are B. So if all cats are animals, then most cats are animals. And once again, this has to do with the specific way in which most is used in logic and formal logic, specifically that it also incorporates the possibility of all. So most means more than half, potentially all. So if all cats are animals, then it's likewise true that more than half and potentially all cats are animals. And so you can go from that one to the second one. The reason you might want to do these, you'll see these in the specific questions that we encounter in the exercises and in the homework and all that, and the videos, primarily the ones that deal with, these are primarily for the sufficient assumption and inference, or must be true and must be false questions, because you'll have to look at a particular statement and think about what the logical implications are, either in terms of that's what you're being asked for, or it's going to be something that you'll need to be able to figure out and identify in order to close the gap between premises and conclusions. So you'll see when we get to these, but there is going to be a need for the ability to recognize when one statement logically implies another. So as I say here, all A and B implies most A or B, and most A or B implies some A or B. So once again, if most cats, potentially all, are animals, then there's at least one cat, potentially all cats, that are animals. It's the same thing, once again, for the same reason. And so you can actually go from the top to the bottom. And so all ARB implies that some ARB. So same thing, just because all cats are animals, that lets you know by definition, logically, that there is at least one cat, potentially all, which are animals. So you can go from top to bottom. You can go from all to some. But you can't go from some to most to all. And that makes sense, because some A or B does not necessarily imply that most A or B. So just because there's at least one cat, potentially all, that are animals, that does not mean that more than half of the cats, potentially all, are animals. You don't know. There could be a situation in which at least one does not necessarily lead to potentially half. And likewise, most does not necessarily imply all. So you can't go from most cats are animals to all cats are animals for the same reason. Just because more than half, potentially all, does not necessarily mean potentially all. And so you can't go from top to bottom. So you can't go from some A or B to all A or B, or as we have here, from some cats are animals to all cats are animals. So that's what you got to remember. You can go from all to most to some, but you can't go from some to most to all. Now, what about the negatives? Well, the same thing. No cats are dogs. Most cats aren't dogs. Some cats aren't dogs. So same thing. You can go from none to most aren't. Some aren't. And no A or B implies that most A aren't B for the same reason, because most implies none. So this is the same. This is the flip, essentially, what we've done in the previous slide with from all to some. We're doing it from none to some aren't for the same reason, because they imply none. Same thing with most aren't, implies that some aren't, and no, therefore no A or B implies that some A aren't B. So no cats are dogs implies that there's some cats that are not dogs. Likewise, you can't go from some are not to most aren't to none. So some aren't B, some A aren't B does not imply that most A aren't B. Same reason, just because there's potential that some, potentially none, some cats, potentially none cats, or no cats are dogs, does not mean that most cats, potentially, more than half cats, potentially none of them are dogs. You can't make that jump from from at least one to more than half. And same thing from more than half to none. So most A or B doesn't imply no A or B, and likewise you can't close that and start from the bottom and go to the top from some to none. So once again, you can go from all to some, and you can go from none to some or not, but you cannot go in the reverse direction. You can't go from some to most to all, and some aren't to most aren't to none. And once again, you'll need to do this in situations where you'll be given a conditional statement, but it's going to be required to figure out what the logical implication of that is, either if you're doing it must be true, or if you're trying to close the gap between premises and conclusion. In terms of the logical connections between statements, so we see here we have a statement that says that S. So some cats are black. Black things are hard to see. Therefore, some cats are hard to see. So what does that mean? Well, statements with quantifiers can actually be connected, but you have to be careful how you connect them. They can't all be connected. There's only specific ways in which you can connect them. So you can connect the qualifiers in a chain of 3, or in a cluster with one leading to 2. So this is a chain of 3 because we've got cat, black, and hard to see, and we're connecting all of that. And then the cluster you'll see in a second when we get there. That's with the most qualifiers. So if you connect them in a chain where A leads to B and B leads to C, which is what we have here, cat leads to black, black leads to hard to see. For some qualifiers, some A or B can only connect with all B or C to yield some A or C. So if you're trying to connect stuff and there's qualifiers, then if there's a sum in there and you're trying to connect it in terms of a transitive chain, so A to B to C, if there's a sum in there, you can only connect that to an all statement. And it has to go some statement first and then all statements. So some A or B, so some cats are black, and then all black things are hard to see, and you'll end up with some cats are hard to see. Some aren't, can't connect with anything to get another statement, and you also can't start first with an all statement and then say that some of those things. So you can't say all cats are black, some black things are hard to see. Well, you don't know if any cat is hard to see. So you can't connect an all to a sum. You can't make a sum be the second in that chain. The sum, you have to start with the sum and then connect it to an all. And you can't do anything with sum or not. If you see any sum or not, you can't connect them to any other conditional statement. So really the only thing that you can connect here, and if you're doing a transitive A to B to C, is if you start with sum and you connect it to all. Likewise, for most A or B can connect with all A or B. With all B or C to yield most A or C. So this is similar in the sense that you are just switching out the S, but it also changes because you can connect it because your final conditional statement is actually most as well. So if most cats are pets and all pets live with people, then most cats live with people. So if you got in most, just like the sum, and you add an all statement to it, then you can make that transitive statement that begins with some. And once again, most can't connect with anything to get to another statement. So you can't, if you see most aren't up there, that doesn't tell you anything. In terms of a transitive linkage. Now, so that's where you're connecting A to B to C. But you can connect them where A leads to B and A also leads to C. So look what we have over here. We say that most cats are pets and most cats are stealthy. So there's some pets out there who are stealthy. So some or some aren't can't connect with anything to get another statement. But for most A or B can connect with most A or C to get some B or C. So think of it this way: you're starting out with the same sufficient. In this case, we've got cats. So a cat is something. Most cats are one thing, and most cats are something else. If you're dealing with most, then there's bound to be some sort of overlap between those two necessary conditions. So if most cats are pets, that means of all the cats out there, more than half of them are pets. But then if most cats are stealthy, that means of all the cats out there, more than half of them are stealthy. So even if they're as different as possible, the fact that it's more than half in both cases means that there's got to be some sort of overlap. Because if you've got 100 cats in the universe and 60 of them are pets, and then 60 of them are also stealthy, well, even if 50 of the cats were pets, they were completely divided. 50 of them were pets and 50 of them were stealthy. The fact that there's 60 of them that are pets and stealthy means that there's at least 10 that are overlapping in some sense. So you can say some pets are stealthy. So when you see two most statements that cluster together in the sense that their sufficient is the same in both of them, then you know that you can have a statement where there is a conditional statement that connects those two necessary conditions like we have here, where some who have one necessary condition also have the other necessary condition. So some pets are stealthy in this case. So that's what you can do with most. You can connect most in a transitive, you can connect some and most in a transitive argument with another all statement, or if you have two most statements, they can both lead to a some statement. Most aren't, cannot connect with anything to get another statement. So you can't do the opposite and say most aren't this and most aren't that, and then say that some aren't that. It's only with most. Okay, so in terms of quick summary, syllogistic logic appears in arguments as either premises or conclusion and functions similar to conditional logic. Some are not, and most are not actually function differently. You cannot activate those syllogistic statements with specific instances, and likewise you can't take their contrapositive. So this is what I've been saying before in all of the situations where if you know that it says some cats are some cats are pets, the fact that you have a cat does not activate that statement because you don't know if it's that cat which is a pet. And likewise you can't take the contrapositive for the same reason. Just because something's not a pet does not necessarily mean it's not a cat. And the more general the more general logically imply the more specific, but not the other way around. So you can go from all to some and from none to some aren't, but not the other way around. And you can only make certain connections to get another statement. So this is where you have a some statement and then it's connected to an all statement, or a most statement connected to an all statement, or two most statements.